Hello, and welcome to our video series on advanced automation principles. My name is Nabil Mishraf. I'm a solutions architect in the automation and programmability team at Cisco. In this video, I'll talk about blank configuration. We'll define what it means and also the importance of making sure blank configuration is valid. So, what is blank configuration? Blank configuration is the configuration state that exists in automation tools and network managers and service orchestrators before onboarding a device, which means it is zero configuration. Per Yang RFC 17950, it is recommended for blank configuration to be accepted per Yang definitions. This allows us in not requiring pre-configuration to exist in NetConf clients, which include automation tools, service orchestrators, in order to onboard a device. Changes to a Yang data model can also render an existing configuration invalid. So it's not only a problem that happens before onboarding a device, but it can happen anytime we make changes to Yang models. We will talk about some cases where this can happen. This is also described in RFC 8407. Non-blank configuration validity can affect backward compatibility as well as interoperability between a server and a client. An example to give you a taste of what this looks like is the introduction of a mandatory node in our Yang updates. We will see an example for this. Blank configuration should be meaningful for a system configuration. Updates to Yang must be backward compatible for several reasons. We talk about backward compatibility here because non-backward compatible changes can contribute to blank configuration not being accepted. New configuration Yang nodes may not be needed by already existing applications. So when updating your Yang model or adding new Yang models, keep in mind that existing tools may not be interested in that feature that you added. So in that case, whatever you added in Yang should accept blank configuration. Also, it usually takes time for Yang consumers to learn and update their tools, to use the latest Yang changes that you introduced. During that time, it is important to make sure that blank configuration remains valid. Upgrades to a database schema will require human intervention if the new Yang model is non-backward compatible. Also, configuration in production may be rendered invalid or lost by a new non-backward compatible change. This depends on the implementation. So these are the reasons why backward compatibility should be preserved after updating Yang models. The general rule is that existing configuration must remain meaningful after updating the Yang data model. And for a newly onboarded device, since there is no existing configuration, blank configuration should be valid and should be semantically correct per the Yang definition that is implemented on the device. In order to ensure this, follow best practices for updating Yang models in a backward compatible way, as described in RFC 17950 and 8407. Also make sure that top-level nodes are not mandatory. We will talk about this in a little bit. I would like to show you now an example for a BGP Yang snippet. On the left side, this is a non-backward compatible change. We added a container BGP with a leaf AS number of type UIN32 and mandatory. This obviously will break backward compatibility. and also renders the blank configuration for this node invalid. The way to solve this problem is by adding presence statements here. In this case, we added presence statement, enable BGP. This means that if there is configuration here, that means BGP is enabled. If there is no configuration, meaning blank configuration for these nodes, that also means it is valid semantically for the device. Means that BGP isn't enabled. Special call out to top level nodes. Per RFC 8407, section 4.10, top level data definitions must not be mandatory. If you introduce, for example, a node at the top level that is mandatory, this will automatically cause the database to be invalid. This also applies to internal nodes in some cases, not in every case. Like we've seen already with BGP, we can still add a mandatory node as long as the parent container has a presence statement. We've talked about mandatory, but these rules also apply to must when min element and max element statements. When making updates to a Yang model or adding a new Yang model, the new constraints shouldn't restrict the existing configuration. We've seen this problem with BGP when we added the mandatory statements that restricted the existing configuration. The way it did that is by requiring that AS number needs to be configured. The general rule when updating Yang model and working with constraints is to make sure that existing constraints must either be removed or relaxed. We cannot add a constraint that restricts and makes the existing configuration invalid. I hope that this is clear now. And we can look at this next example. In this example, we have a pre-update model, which contains this configuration. As you can see here, if my device doesn't have configuration for these nodes, it will still be valid. Post updates, we added a must statement here, which means we restricted the value of foo-foo by using a must statement. This already breaks backward compatibility and renders blank configuration invalid. For example, if my pre-update configuration, I had this leaf already set, while this one is not set, in the post-update configuration, this will be invalid because leaf foo-foo would need to be set since bar is set. Also, the same problem applies here if we add mandatory true. This shows you that just by adding semantics, new semantic constraints in your updated model, you can render blank configuration invalid. And this breaks backward compatibility. This is the end of my presentation. I hope this is now clear to everyone. And these are the list of resources that you can refer to if you would like to learn more. Thank you.